After learning about all of those terminologies, the next obvious question should be, how do you find them? One of the ways is your first derivative test. As the name indicates, it has to do with derivative, differentiation. The first derivative test is a technique used to identify points of local maxima and local minima by solely analyzing the first order derivative. That is, you differentiate it first and analyze this, look into this to understand the extreme points. How do you do it is something that we're going to see in this video. So the theory starts with this. If f is a continuous function in an open interval, right, then we can find the local maxima and local minima by the following concept. So I'll go to the actual diagram. So this is local maxima and this is local minima. Now, if I draw the tangent before and after the turning point, there would be something like this. Let's look into the nature of this. So this is clearly negative and this is clearly positive. This is clearly positive and this is clearly negative. So looking at the slopes, can we talk about a way in which we can tell this is local minima? Whenever we have a scenario wherein the differentiation of the function before the turning point, if it's negative and then it turns out to be positive, that would be local minima. If the slope turns out to be positive and then negative, it will be local maxima. Okay, let me take up this example. So the one thing which we are very clear with is over here, right? This is your local minima and actually global also, but anyways. Now here, what is the slope before the turning point? It is negative. And after the turning point, as you can see clearly, it is positive. So we have negative and positive, so giving us local minima. And over here, as and when we move across, this is positive and after the turning point, it turns out to be negative. So positive and negative, it is local maxima, right? So depending on this funda, we'll be able to tell if it's local minima or local maxima. Okay, how do you find the turning point? You equate the function to 0 and you're done. Okay, don't worry, we have the steps written. So this is how you find it. So the write-up also tells the same before A, C and B. So if I call this as A, C and B, and this is A, C and B. So this is maxima, this diagram. So on to the left, this talks about left of C and this talks about the right of C. So the right of C, you can see it's negative as it's described over here. To the left of C, it is positive. And so here as well. A to C, it is negative, and C to B, it is positive. Okay, so we saw an example. Now there is another possibility as well. That is, before the turning point and after the turning point, if the slope, the nature of slope turns out to be the same. So in this case, it is positive and again positive. This is neither a maxima or a minima. This is the slope wherein you have it to be 0. Okay, here too the slopes are 0. That you guys know already. I don't want to talk about that. So this is your point of inflection, right? I hope you guys remember this. So in this case, we don't have a maxima or minima at that point. So the step involves finding the derivative that I am sure you guys understood. Finding the zeros by equating it to 0. So I am calling this as A1, A2, so on and so forth. That's where the slope is 0, right? Point where the slope becomes 0. That's why we are equating to 0. Okay, so basically f prime of x, you equate it to 0 and you'll get all the required points. All the turning points basically. So these are your turning points. And then we have each point of the above, we have to consider those points. Check the nature of the point before and after. So if it turns out to be positive, negative, it's maxima, negative to positive, it's minimum. And if there is no change in sign, then it's point of inflection. Okay, so we have the following. I have an example for you guys. A quick example, I won't go to the detailed answer of this. So what we have here is f of x, I'll find f prime of x. This is 12x cube plus 12x square minus 24x and a 0. I need to factorize this. So that would be your second step. For that, I'll take up 12 and x. This is x square, x to the power of 1 minus 2x minus 2. And I need to factorize this. The factorized form is, I'm going to directly write as x plus 2 into x minus 1. Okay. And from this, I'll find the zeros. So that would be a simple 0 and 1 and minus 2. So I'll write it in order, minus 2, 0 and 1. Okay, let's have a look at this. So this is an example or the same equation, that is. And we have seen this before also. So this is your 0, exactly, I jumped onto this. That's your 1. So here too you can see it's almost, yeah. And then we have 0 again for 1, right? Now all I have to do is check the nature of the slope before and after, say 0. So this is a tedious process, of course. So checking nature of sign. So say around 0. I'm just going to do it for 1. So f of 0.5 maybe. So that is left of 0. Let me do it a bit more neater. So f prime of minus 0.5. So that would be, where is it, over here? So this would be a negative outside, and with the first one it would be positive and again negative. So overall it is positive. And next we'll look at right of 0. So f prime of 0.5. So that would be positive and then positive and then negative. So this will be, overall answer is negative. So as you can see from this graph, at 0 what is happening? It's a peak, is it not? It's a local maxima. Can you see that? It's a local maxima. Right? It's a local maxima. Here the slope is positive and then it's negative. That's what we got. So from this I can infer that 0 is local maxima. So for this, similar to this, we have to find for minus 2 and 1 and so on and so forth. It's a tedious thing. I agree. There is an alternative to this that we'll be seeing in the next video. For now, you guys have to copy all of this. Mainly copy the graph. Other things are something that you guys have to understand and write it. If you draw the graph properly, then things becomes very simple. Draw mainly the graphs and write the other things that's left to you guys. Steps you guys have to write. And finally, an example.